Now, this one's kind of weird. When I'm writing the zeros of this polynomial, it has 3 different zeros. But what do you guys know about four-theory polynomials? Because almost everybody knows this. It should have 4 zeros. Where's the other one?
It's the x squared.
It's the x squared. It's not imaginary because you can't have one imaginary zero with real
Right.
coefficients. X squared equals 0 is really x equals 0 or x equals 0. That thing is 2 of the 4 zeros. It doesn't say they have to be 4 different zeros. It just has to be 4 of them.
That's tricky.
When something like this makes 2 zeros, this 0 is said to have multiplicity 2. If the factor produced 3 zeros of the same thing, it would have multiplicity 3, or multiplicity 4, or so on and so forth. We don't get that.
So if it
carried
was
away.
x cubed equals 0, it would be multiplicity 3?
3, yeah. Or if this, for instance, if we'd had x minus 4 squared, then 4 would have had a multiplicity of 2 because that would have been 2 of my zeros. Now we're going to skip finding the the y-intercepts and the end behavior of this because I want to get to this problem. Find the possible formula for a polynomial of degree 4 that has a root of multiplicity 2 at x equals 2 and roots of multiplicity 1 at x equals 0 and x equals negative 2. And it goes through this point 5, 30, 63.
Holy cow.
This sounds terrible, doesn't it? It's an awful lot of words, but really it's not so bad. Here we took our polynomials and broke them down. Here we're going to build it up. It says it's a degree 4 polynomial. How many zeros does that mean it should have? 4. So I'm looking at my steps. I go from here to here to here where everything's equal to 0, like right here. And then I get my zeros. So I'm going to go with, I need to have 4 of these things. X equals something, x equals something else, x equals a third thing, and a 4th thing. These are going to be my zeros. This is going to be the step right before I made points. What numbers am I going to plug in here based on what it says there? 2. Why do I plug in 2 twice?
Multiplicity 2.
Because I was told it had multiplicity 2. That means it came out of there twice, all right? 0 and negative 2. How did it look right before this? What did the step before this look like? Well, if we look here, we had x equals 4. The step right before that had x minus 4 equals 0. So I move it over to the other side. Here I'll have x minus 2 equals 0. Here I'll have x minus 2 equals 0. Here I'll have, well, that's already x equals 0. And this will be x plus 2 equals 0. Now what did it look like before this step? I multiply them all together, so I'll have x minus 2 times x minus 2 times x plus 2. Now, here's where things are a little different. This is the basis of my polynomial. But in the process of solving for 0, I could have lost my leading coefficient. And so I need to put it back in when I multiply them back together. So I'm putting in a for the possibility that a was something I was able to divide out. And then this is now the basis for my function. This looks an awful lot like what we did in that problem 6 where we had our vertex form and we plugged in our pieces. How would I find a? Yeah, just like with vertex form, this point is going to do it. It says when I put in 5 for x, I should get out 63. So I'm going to solve for a by making this 63 equals a times 5 minus 2 times 5 minus 2 times 5 times 5 plus 2. So I have 63 equals a times 3 times 3 times 5 times 7
35 times 9?
I think it's 315.
315.
So 63 equals A times 315. When I divide 63 by 315, I will have what A is. You can simplify that if you want, you do not have to. Some of you may have already looked at it and go, oh, that's 1/5. If you don't see that, it doesn't matter. So, but am I done with my polynomial? Not quite. I now know what A is, so I need to finish writing my polynomial.
Calculator for that. You're being a stupid kid. What are you doing in college?
My polynomial will be f of x equals A, which we got to be 63 over 315, times x minus 2, times x minus 2, times x plus 2. And there's my polynomial.
You can't
That-
just put x minus 2 squared.
Yes, you can. If you wanted to write this x minus 2 times x minus 2 is x minus 2 squared, you can do that. But you don't have to. Like I said, the way it checks functions is it plugs numbers into your function and its answer function, and if you agree on most of the outputs, then it says, okay, your function's the same as mine. No matter, so for instance, the order you put these in is unimportant. If you really feel like multiplying them out, you can.
I was gonna
I
say,
wouldn't recommend it, that's way more work than you need to do.
Because it
Factored
just-
is a whole lot easier for everybody, especially me and Jared, when it comes time to grading it. If we can see it factored, we can know that you did it right. If you multiply it all out, we're going, no, please don't make me look at that.
x squared plus 2x wouldn't work in that last
I
part.
guess you just assume it's right if we factor it all out. Give us the points. to
All
save
right.
yourself time.
Now,
Can't we be smarter than the teacher and the TA?
we did that one already, let's look at
Maybe
this
teacher.
one. There is a standard word problem that comes with this stuff. And that word problem is this.
I hate these.
A box without a lid is constructed from a 36-inch by 36-inch piece of cardboard by cutting x-inch squares from each corner and folding up the sides. Let's take a look at what that really means. How many of you have made these boxes before?
Buy a box.
Oh,
Oh, good, here we have.
never. Never gonna work in a warehouse.
So the way this is set up is I have a piece of cardboard. It's supposed to be square. 36 inches by 36 inches. From each corner, I cut out a square that's x by